High brightness LED drivers. Welcome to this training module on Maxim high brightness LED drivers. This module intends to provide you with an overview of the high brightness LED driver ICs. You will learn about the three basic types of LED driving methods and a selection of different products in terms of applications. In recent years, high brightness HB LEDs have gained prominence as the lighting source for a variety of applications. HB LEDs are rugged and reliable semiconductor devices capable of several tens of thousands of cycles, up to 100,000 hours of operation. That performance represents an operating life that is orders of magnitude longer than conventional incandescent and halogen lamps. Thus, HB LED applications can be found in automotive lighting, public and commercial signage, and architectural lighting. HB LEDs are PN junction devices especially processed to produce white, red, green, and blue light when forward biased. As PN junction devices, LEDs exhibit VI characteristics similar to those of conventional diodes, but with higher voltage drops across their junctions. Little current passes through an LED until the forward voltage reaches V sub F, which varies from 2.5 volts for red LEDs to about 4.5 volts for blue LEDs. When V sub F is reached, the current increases very rapidly, as in conventional diodes. Consequently, the designer must employ current limiting to prevent possible damage. LEDs are current-driven devices in which the light output depends directly on the forward current passing through them. A simple biasing circuit that maintains the current and consequently the light output at a reasonably constant value matches the intended power supply with a single current limiting resistor connected in series with the LED. A simple constant current regulator uses an operational amplifier with an input voltage range that extends to the negative rail. The voltage drop across a current sensing resistor is compared to the reference voltage, and the amplifier output voltage rises or falls to control the current. The voltage reference can be a Zener diode. The Zener diode generally has a smallest temperature coefficient and lowest dynamic impedance at a breakdown voltage. Linear regulators are step-down regulators only. That is, the input voltage source must be higher than the desired output voltage. The basic switch regulator uses a transistor as a switch that alternately connects and disconnects the input voltage to an inductor. The current pulses are smoothed by the external inductor, diode, and capacitor. Current feedback from the sense resistor requires more components than shown here, but the basic principle is the same. The current is compared with a reference and the output of the regulator, and the output of the regulator adjusts itself to keep the LED current constant despite falling battery voltage or rising LED temperature. As PN junction devices, LEDs exhibit VI characteristics similar to those of conventional diodes, but with higher voltage drops across their junctions. Little current passes through an LED until the forward voltage reaches V sub F, which varies from 2.5 volts for red LEDs to about 4.5 volts for blue LEDs. When V sub F is reached, the current increases very rapidly, as in conventional diodes. Consequently, the designer must employ current limiting to prevent possible damage. LED driving can be implemented with three basic methods. The table shows advantages and disadvantages of each method. Maxim's high-brightness LED drivers include 25 products covering the full range of linear and switch mode topologies, such as boost, buck, flyback, and SEPIC. The family contains all the circuitry required for the design of wide input voltage range LED drivers for general lighting and display applications. Each ICs in this family is able to drive multiple LEDs. Even the MAX 16809/10 LED drivers contain 16 constant current output channels. The dedicated PWM inputs control the duty cycle of the output current, allowing a wide LED dimming range to be implemented. These devices operate up to 2 MHz switching frequency, thus allowing for optimization of the magnetic and filter components, resulting in compact size. Additional features include adjustable constant output current, short circuit protection, and thermal protections. Here's the selection table for linear high brightness LED drivers. Here is the selection table for switch mode high brightness LED drivers. These HB LED drivers are dedicated integrated circuits for white or RGB LEDs. They are energy-saving, cost-effective choices that enable the next generation of LCD backlighting, projection, automotive, and general lighting applications. Interior lighting applications include cluster or instrument backlighting, dome or map reading lights, and courtesy lights at doors or in the trunk. All these interior light applications can use LEDs as a light source. While map and dome lighting are often implemented with one LED, cluster and courtesy lighting normally requires more than one LED connected in series. All the applications need a regulated constant current source with an integrated dimming function. The MAX16800 has a high input voltage range, up to 40 volts, so it can connect directly to the car battery without needing further protection against voltage surges caused by load dumps on the battery network. The device generates a constant current for the LEDs that can be set by the sense resistor, R sub sense, in series with the LEDs. The color of an LED varies with the current flowing through it. Dimming LED brightness is therefore better achieved by pulsed width modulating, PWM, a constant current than by actually changing the current magnitude. The MAX16800 dims LED brightness by applying a PWM signal to the enable input. The current through the LEDs is turned on and off at the rate set by the PWM signal. In order to reduce the radiated EMI during PWM dimming, the MAX16800 uses wave shaping circuitry to smooth the switching edges. Today, more and more liquid crystal displays, LCDs, are used to display information in instrument clusters, car computers, radio and navigation systems, and entertainment systems. Moreover, display backlighting diffuses light across a large area instead of generating a focused light beam. LCD backlighting is to use a matrix of LEDs, providing homogeneous illumination and color over the full area. The MAX16807 and MAX16808 can be used in buck, boost, or SEPIC mode depending on the input voltage range and the number of LEDs in series per output string. Adding an external resistor and a Zener diode, D, makes the device load dump proof. While the current through all strings is set by only one resistor, the current of each string is regulated individually. This architecture achieves better than 3% current matching between the individual strings without needing additional external components. While each string can be dimmed individually to adjust for binning mismatches, all strings can be dimmed together through the enable pin. With a dimming frequency range of 50 Hz to 30 kHz, a dimming ratio of 5,000 to 1 can be achieved. This high ratio is necessary for automotive displays that must be viewable both in the dark and sunlight. The adjustable switching frequency range from 20 kHz to 1 MHz makes it possible to select a frequency that will not interfere with other systems like radio receivers. Exterior lighting applications raise new issues of security and safety and demands for even more high-power illumination, such as tail lights and emergency warning lights. Tail light lights need to be visible over long distance but must not illuminate a wide area. The MAX16800, 16807, and 16808 power supplies are also appropriate for this application. Because the number of LEDs in a tail light is typically higher than in the interior applications, more than one of these power supplies will be needed. Multiple power supplies also provide the necessary redundancy to guarantee operation even if one of the circuits fail. Very high brightness LEDs must be used for applications that require high illumination power, like floodlights or fog lights. HB LEDs require very high currents, so the MAX 16818 is the solution for these HB LED applications. It can provide up to 30 amps of current. Exterior lighting applications must typically turn on fast or switch brightness instantaneously. To achieve this, the MAX 16818 is the first LED driver that uses Maxim's average current mode control technology for fast LED current transients of up to 20 amps per microsecond.